Okay, we are live. Hello, everyone. We will get started in about 1 minute, just to give everybody time to join. Okay, we're going to go ahead and get started. Hello, everyone, and welcome to today's session. I would like to introduce you to our presenters, Gil Trotino and Had Rotem from K2View, who bring a combined experience of over 20 years serving enterprises in data-intensive, operational, and analytical workloads. Today's session, Reducing the Risk of Data Breaches with a Data Product Approach to Data Tokenization, is being recorded and will be made available on the BrightTalk platform after the webinar ends. During our session, we will present 3 poll questions to which we would love for you to respond. We will share the anonymized statistical results of the polls with our audience. Finally, we will have a Q&A session at the end, so please jot down your questions in the questions box, and we will try to attend to as many of these as possible at the end. With that, let's get started, and I'll turn it over to you, Gil.
Thank you very much, Alyssa. Hi, everybody. I hope you can hear us well, and thank you very much for joining this webinar on data tokenization. My name is Gil Trotino. I'm a Director of Product Marketing at K2View, and delivering this webinar with me, and the guy that will drive the live product demo is Had Rotem, our VP Solutions and Innovation. Hi, Had.
Hi, everyone.
Let's start with the topics we are going to cover today. Protecting sensitive data, as we know, is a top priority of enterprises. So in this webinar, we are going to focus on data tokenization, which is becoming more and more common and is actually one of the best data protection methods. We will start by discussing what are the business drivers, what drives organizations to deploy data tokenization. We'll talk a little bit about use cases and the key benefits. And then we'll talk on some of the limitations and challenges of the traditional data tokenization solutions. Had will take us and explain the K2View multi-vault data tokenization solution and will demonstrate our solution as well. And then he will further explain how, using the data product platform of K2View, you can actually take data tokenization to the next level and deploy a tokenization 360, which is even more powerful, and we'll explain all about it later on. As Alyssa mentioned, we will have a Q&A session at the end of our session. We'll try to take and address as many questions from the audience, but we promise also to answer all the other questions via email if we do not accommodate them during the session. We also will have these 3 poll questions. Please share with us your feedback. It's really important for us to get to know what you do in this area, what are your requirements and expectations. So this is very important, and please share. And without further ado, let's start. And let's start by looking into data breaches. And actually, only in 2021 and the beginning of 2022, we've seen 1,800 significant data breaches that were publicly announced. And as you can see here, it's coming from all sorts of companies, from all sorts of verticals. And actually what we see is a jump of 70% from the previous year to 2021 in the number of data breaches. It's not only the number of breaches, we also see a growing number of internal threats. So according to some researchers, 60% of data breaches in 2020 actually were coming from insiders, as you can see here. We also see a growth in the cost of a data breach. The cost of a data breach, according to a latest IBM report, actually rose 10% year over year. So it means we have more data breaches that we see, the cost is higher, and this is probably one of the reasons that we see that top business leaders actually avoid sleeping at night, because they do view threat of cyber attacks as one of the top risks on their list. And actually, this is one of the biggest concern. They all know that non-compliance with data protection laws could lead to high penalties, to legal litigation, and also to brand damage. So all this basically brings us to the need of enterprises to protect the sensitive information. And it's not surprisingly that if we look into the main business drivers that we see with our customers that drive them to deploy a data tokenization solution, the first one is going back to this data breaches, the need to reduce the number of data breaches. And we will see very soon tokenization, by replacing sensitive data with non-sensitive data, which are the tokens, actually enables these organizations to reduce the occurrences and the footprint of sensitive data in their systems. And by this, they can significantly reduce the number of data breaches and increase the protection of their data. The second driver relates very much to this, and this is to meet compliance standards. As we know, we see many different compliance standards and regulations in different parts of the globe. Some of them are regional specific, like GDPR in the EU, or LGPD in Brazil, or CCPA in California. Some of them are more industry specific, like HIPAA for the healthcare, and some of them really relate to specific pieces of sensitive data, like the PCI DSS, the payment card industry data security standard, which relates specifically to the financial services and to protect credit card information and others. So this is a second driver. But there is a third one, which we see in many of our customers, and this is cost reduction. Tokenization, by the fact that we apply a centralized tokenization solution, eliminate the need of organizations to invest huge amount of money and huge effort in protecting sensitive data across so many applications and databases. By eliminating the sensitive data, they can really also reduce this huge effort and cost that they need to spend on encryption software, on software licenses, and other costs of protecting data on the different application by application. And the fourth driver has a lot to do with the rise of online payment technology and also the rise of cyber attacks, which relate to financial information. So these are the four key business drivers that we see on data for data tokenization. Now let's go and try to define what is data tokenization. And the very basic definition talks about the process of substituting sensitive data with a substitute or a token, which is a non-sensitive equivalent. And the fact that we substitute the sensitive data with a non-sensitive data or a token means basically that all the different business applications can keep on continuously operating as they need to do, without the risk and without the need to secure this sensitive information, because they deal only with the token. The only place where the token is mapped to the sensitive information is in the tokenization system or the tokenization server, but the different parties that deal with the data actually cannot reverse from the token to the sensitive information. This is what makes the tokenization such a powerful solution. So the token itself is irreversible. Normally, when you talk about tokenization, we'll see tokens that, although are unrelated values, normally they will retain some certain elements of the original data, mainly the length and format of the original data. So this means, again, business applications can continue in an uninterrupted way to work, to do the business, to analyze the data, and to do whatever they need. This is a very important distinction between tokenization and other methods. And maybe this is a good point to try to clarify some of the very delicate differences between three types of data protection methods. And I'm talking about encryption, masking, and tokenization. So let's talk a little bit about terminology, and let's try to clarify the differences. So when we talk about encryption, which is a very commonly used method, we talk about some mathematical mechanism or algorithm that convert the sensitive piece of information to an unreadable block of text that basically can't be converted unless you have the encryption key. So for example, if I need to transfer sensitive data to HOD over the network, I can encrypt the data with a key. I can send it over encrypted over the network, and then HOD with the key can decrypt it again and get access to this sensitive piece of information. So what we see with encryption is this ability to reverse the encrypted data is actually one of the biggest weaknesses of the encryption method. And what we see is that the level of protection of sensitive data will be always determined by the complexity of the algorithm used to encrypt it. However, all encrypted data can ultimately be reversed and broken, as we know. Still, encryption is very highly used to secure data exchange, like we just explained, also to protect data at rest, so to protect the data while it's being stored, and then we decrypt it before we provide access to it to authorized users, a very well-known method. The second method of replacing sensitive data with non-sensitive data is actually data masking. And with data masking, basically, we substitute realistic but false data for the original piece of data. Here, basically, what we'd like to achieve is to get a lookalike. The masked data will look very similar in terms of the format and shape to the original data. However, the masked data is normally, in most of the cases, irreversible. So we will not be able to take the masked data and to generate the original data. Typical use cases for masking would be when we want to generate test data for our testers, for test environment, and we require very realistic lookalike data, which we would like to use for testing. Another good example is all the ability that we wish to have to generate analytics, and by this we first need to ingest data to data lakes and data warehouses. And once again, if we want to protect the data, we can use masking to eliminate the sensitive data and enable business analytic applications to generate insights based on this masked data. And this brings us back to tokenization, which again, we talk about a reversible process. However, the only place where this reverse can take place, is using the vault. So the vault or the tokenization server, this is the only place where the sensitive data is mapped to the tokens. Unless we go and approach the tokenization server, the different parties cannot really take the token and reverse it back. And therefore, this is one of the most powerful solutions. And again, very much used in the payment processing systems and protecting other piece of sensitive information. This is actually, I think, a good place to ask you a question, and to Lisa, if you can just post our first question. Basically, we'd like to ask you to share with us what type of security method do you use out of these that we've just highlighted here.
Okay, the question is posted. So if you'll just take a second to answer it.
Yeah, we'll give you a few seconds to answer, and we'll continue. So basically, we'd like to ask you whether you use encryption, data masking, data tokenization, maybe a mix of the above, or none of the above. Please tell us which method do you use in your company. Guys, please share. We'll appreciate you share your feedback on this. And of course, you can already post your questions in the question box. And again, we'll get to the questions later on during the session. Okay, we see already some interesting answers. Okay, we'll keep the question on, Alyssa, and let's continue. And please provide your answers. We'll share them with you guys later. So we talked a little bit about tokenization and what differentiates tokenization from other security methods. Let's talk a little bit about where we see the common use cases when we talk to our customers that consider or implement data tokenization. So once again, the first one is always to avoid security breaches. As we've explained, when we reduce or eliminate sensitive data from applications, therefore, of course, we are less exposed to security breaches. And these applications can freely use the information without the risk of exposing the sensitive information. The second one goes back to compliance. It's much easier to ensure compliance when, again, you reduce or eliminate sensitive information from your applications and systems. Also, data access management becoming easier. You get more control over data access management when you deploy data tokenization, because you prevent those without appropriate permissions from detokenizing the sensitive data, and again, to expose this data. Number 4 is very interesting. Many of our customers would like to share information with third-party vendors and suppliers. When you use or apply tokenization, once again, you can make sure that this data can be shared with third-party companies without risking your sensitive or personal or financial information, because you're going to use tokens instead of the sensitive information. And finally, the last one goes back to what we mentioned earlier, the ability to ingest huge amount of data to data lakes like Google BigQuery or Snowflake, or data warehouses like Teradata, and enable business analytic applications to run and to generate business insights using this data without exposing any sensitive information is another use case that we see that drives the use of data tokenization. So these are just 5 of the leading use cases where we see customers applying or consider to apply data tokenization. Now let's briefly summarize what are the key advantages of data tokenization. The first and foremost is, of course, we reduce the risk. We have less sensitive information in our systems. We centralize the tokenization in one place, and therefore we reduce the risk and the ability to expose data and get the data breaches. The second one is that we can reduce a lot of cost that today is associated with encryption, a lot of software licenses that are needed to apply encryption on many different applications and systems, and of course a lot of effort that is spent today to secure each and every application that deals with sensitive information. Reducing privacy efforts, we explained it, I think, several times. And finally, we keep business continuity. So by replacing the sensitive information with this token, with the lookalike, we basically provide the business application the continuity they need, and they really can freely process the data without any risk of exposing sensitive information. Now we'd like to ask you another question, and this is more focused about data tokenization. So I hope you managed to provide feedback, and actually we've seen that some of you are already implementing tokenization. The second question, and Alyssa, if you can push out the second question, is if you have any plans for implementing data tokenization. Maybe you've done it already, maybe you consider to do it, maybe not. Please share with us what are your plans, if any, to apply data tokenization in your organization. So meanwhile, I'll just share with you some highlights of the previous question. So the previous question we asked you is about which method do you use for protecting sensitive data. So basically, most of you are using mix of the methods. 10% are using encryption, 10% are using masking, 10% tokenization, and 40% are using the mix of one, of two, or three of those. 30% answered that they use none of the above. So 30% of the audience are not using not encryption, not masking, not tokenization. I guess you're using something else, which was not on the list, or you are still looking for your best security solution. So please now tell us about your plans for implementing data tokenization, and we'll share with you the answers later on during the session. Now I'd like to turn it over to Hod. Hod will take us through the K2View solution, the multi-vault data tokenization solution, and will also take us to a live product demo showing us how we do it with the K2View data product platform. Hod, would you like to share the screen?
Yeah, thank you, Gil, and hi, everyone. I'll just run through a few slides before I take control of the screen. So Gil explained some of the important benefits of data tokenization, why a lot of companies are interested in implementing one. But as you design how you might implement tokenization within your organization, it's important to understand some of the key limitations that existing solutions have in the market and some of the business requirements that will show you will come along as you design and implement your solution. So the first key limitation is associated with scaling. The more you add to your tokenization solution, the more system you onboard, and some customers might have hundreds or thousands of different applications that are onboarded into a tokenization solution, the more requirement from a throughput and performance you're going to have on this solution, the more calls per second. It's important that when you design your tokenization solution, you consider distribution and high availability and scaling with the ability to support thousands, if not tens of thousands of calls per second to tokenize and detokenize data. Another key limitation is associated with how the data is stored within the data tokenization solution. The traditional data tokenization solutions that exist in the market, they essentially give you a vault where you store all the secure information in. Now, where before you stored the original data in the source systems, in the system of record, and now they're tokenized, you essentially move the risk from this source system and into your tokenization solution. And having one big vault that stores now data from all the systems, not just from one, but from all the systems, it's a major risk if that vault is to be broken into. Another key limitation is associated with the referential integrity and the formatting of the tokenization. It's not enough to say, I got a value, I return a token instead. You also need to consider that different systems store this value in different formats. For example, one system might store social security as a 9-digit number. Social security, for those out from the US, is a unique identifier for a customer, for a person in the United States. So some system might store it as a 9-digit number. Some system might store it as a 3-digit space, 2-digit space, 4-digit number, and other variations, but they all represent the same value. So when you tokenize it, you have to output the same token to keep consistent and integrity in those systems even after you mask and secure them. So some of the key requirements that we see our customers looking when they talk about data tokenization, firstly, it's naturally the data has to be unique. The token that you produce has to be unique. If I take two values and produce the same token, you don't know when you need to detokenize the data, which value to return. So across all these hundreds of thousands of systems and across tens or hundreds of calls per second, you need to be able to understand how to token and detokenize the data in a unique way. But unique is something that is associated with a scope. And some customers want to always produce the same token no matter what, in what format and what way, and from which system the value is arriving. Some customers, some companies want to tokenize it based on a scope. For example, every time I get the ABCD input from the development environment, I'll produce XYZ. But if I get the same ABCD input from the production environment, I want to create a different token for it. So you have to consider the scope when you tokenize and detokenize the data. It still has to be unique, but potentially the same input can produce a different token depending if it's coming from maybe the CRM system or the billing system or production or UAT, or maybe for an individual customer. Every time I get John Doe that is associated with customer number 1, I want to produce Steve Smith. But if I get the same John Doe from customer number 5, I want to produce a different token, because then the data doesn't always look the same in the secured environment. You're creating additional risk if you always tokenize John in the exact same way. Another item of key requirement that we see in the tokenization solution is associated with data expiration. It's very common for our customers and companies to want to rotate the tokens in the key. We call it key rotation. Say token is going to be valid for the next unit of time, and after a point of time, I'm going to change it to a different token, because if I always consist the same token, every time I get John, I produce Steve, eventually it will become easier to break this information. So expiration or time to live is the ability to define an expiration on the token. After a point in time, this token is eliminated, deleted automatically, and a new token, a new value will be generated. And of course, when we talk about requirements of tokenization, it's not just about the ability to tokenize, but the ability to de-tokenize the data in different formats, in different ways. One of them might be to go to the original system of record and collect the original value. Another one will be to go into the vault and produce the tokenized value. But there are a variety of ways to de-tokenize the information. So let's talk more specifically about K2View and what type of modules and offering we have around data tokenization. There are a few that K2View offer. We're going to talk about a couple today. One of them is the PII, Personal Identifiable Information Discovery model. This is a model that helps you discover where you might have data that you need to tokenize. It helps you scan your system to say that in a 40-year-old mainframe system that you might not even have the knowledge how to maintain anymore, and the people that used to work on it have retired or moved on to other position, there is a social security number in a column called ABCD in a table called XYZ that you never even knew about. So to help you scan the system to find where you might have data that you know that you want to tokenize for security purposes. And then once you scan the system, we'll talk about how we tokenize it using our multi-vault tokenization solution and what benefit the multi-vault tokenization solution offers. So let's start with the PII discovery. I will share my screen, and Gil or Alisa, kindly just let me know that that you can see this.
Yes, we can see it.
Thank you. Okay, so I'm going to load into my PII discovery module. And again, the PII discovery is meant to help you scan your system to identify where data that you want to tokenize exist. And it enables a variety of different ways to scan the data. The first one is a column-based scanning. This is a metadata definition scanning. We look at the name of the column in the database or the name of the key in the file, and we run pattern matching on top of it. For example, if a column has an address in it, but it's not address ID, then I'm 92% sure that this represents an address column. Or if it has one of these many values, then I'm 90% sure that it's a telephone number. Or maybe if it has DOB or B_date, then it represents a date of birth. This looks at the metadata, the naming definition, and scan it to run pattern matching to identify whether it matches certain PII element. And this is a very traditional and very simplistic way of scanning the data, but K2View offers a lot more than just that. Another model that we offer is data scanning. This actually goes table by table, row by row, column by column, value by value, and run matching on top of the value itself. And if the value itself matches this complicated pattern, then we're sure that this is an email address. And if it matches this complicated pattern, then we're 80% probable that it's a telephone number, because at the end of the day, if you have a 9 or 10 digit number, it might be a telephone number, it might not. And of course, you can create and define your own rules. The objective is to give you a configurable product that you can configure based on your region of the world, based on your business, based on your industries, to go and scan the information that might apply to you. A more advanced mechanism of data scanning is data sampling. This gives us the ability to take a sampling of the data. Maybe your system, you support 500 different languages that you offer to your customer. So knowing that list of 500 languages, we can use that to go table by table, column by column, row by row, value by value, and compare it in a very efficient way, in a very performance and storage or efficient way against this sampling that you gave us in order to tell you this column represents a language. Or maybe you have 300,000 different last names in your system. We can use it as a sample to look at the value, and if it matches about a certain threshold, that we know that that column holds a last name information. And even a further and more advanced mechanism is the ability to scan the data using functions, using data processing objects. In this case, I added a couple, one that discover whether a column or a value is a social security, and another one that discovers whether the credit card. And this is a configurable tool that you can design your own logic. In the case of data discovery for credit card, we design a logic that checks if a credit card is valid, looks at the prefix to see if it's one of the credit card provider, Amex, Visa, etc. Look at the last digit and see whether the combination of all the previous digits calculated by the checksum algorithm produce the right value, if the length of the credit card matches the prefix. All sorts of rules that give you a higher probability that the 16-digit number actually represents a credit card because it complies with all these checks. So now that we've defined different ways to go and scan the data, we can configure which systems, which files, which environments we want to scan the data on. In this example, we have different technologies, DB2, Postgres, I think Oracle, MySQL, and we can define which schemas and which table pattern we want to mask, we want to discover. We can define which schemas or table patterns we want to not scan. For example, if you have a table that starts with the word sys, it might be a system table. We don't want to scan that. There's no purpose in doing that. And then once all this definition is in place, you can schedule or run the discovery. You can connect it to your automation CI/CD process, so it runs with every new deployment, with every new version. And in this case, you can see we started execution number 2. It is going to run on 4 different systems, 4 technologies across 4 different schemas, and it identified 174 tables across this system that it needs to scan. And it's probably already completed. The whole thing took about 5-10 seconds. It's very, very quick. And it produces a report of all the potential PII data that you might have in your system. For example, here, we found that in a system called BillingDB, in a schema called Billing Products, there is a table called CC Info that has a column called SSN, and using the data function scanning, we identify that it's a social security number. We also identify that using the column metadata definition. And we can go and scan and look at all the information that the system discovered. Here's another example for email. Again, it discovered an email address in a different system based on the name and based on the data itself. It matched the data to a pattern that is email. Or if we go and let's look at the credit card information. Again, you use the data function to look at the digits to match that the prefix is one of the known credit card provider and the length matches that credit card provider and the last digit matches the checksum algorithm. To identify which tables and which fields might hold credit card. It even was able to find that in complex objects. For example, here there is a JSON example. And within a JSON, it was able to scan the information and tell you that that JSON contains all sorts of data, gender, religion information, social security, credit card. He was even able to do that in a zip format of a JSON when the file is zipped and not stored as a pure JSON. So you can scan even blob in databases that contains files or contain zip information of files, and it will give you the results. So now that we've looked at PII discovery and we scanned our system and we understand what the data we want to tokenize, let's talk more specifically about a multi-vault tokenization solution. So our multi-vault tokenization solution enhances the traditional tokenization by adding a level of security that takes each tokenized value and creates a dedicated vault for it. We talked about one of the key limitations of tokenization solution in the market, that all the data is stored in one big vault, and if someone broke into that vault, they got all the data about all your customers from all the hundreds of thousands of different products. With K2View, we take each tokenized value, each name, each social, each credit card, and store it in its own dedicated vault. And that vault is encrypted with its own unique key. And that means that instead of having one big vault that you've broken into, you got everyone's data, you now have millions or hundreds of millions of little vaults, and each little vault has a different key that contains data just about that individual token and original value. And by the way, even within the encrypted vault, the micro vault, the data is encrypted. So if somebody is able to break through network and firewalls and into one of the distributed nodes, because we're a distributed system for availability and disaster recovery, and into one of our databases and decrypt one of these vaults, they get an encrypted value of the original value together with a token. Layers and layers of security to make sure that not only your source systems are not tokenized and secure, but also your tokenization solution is secure. And actually, you can integrate with this tokenization using standard protocols like APIs, which we're going to show today in the demo, file streaming. You can even do batch tokenization and de-tokenization activity. Take an entire system and tokenize it, or entire environment and tokenize it at one go. So what we're going to show quickly in our demo today, we're going to start by configuring a new token to expose to the outside world. We're going to talk about the retention, and we're going to do all that using APIs to show how easy it is to integrate into the solution. So with that in mind, I'll log into our tokenization solution. The tokenization solution comes with its own long list of predefined tokens, but the idea is that you can build and configure and enhance to create tokens that are applicable to your organization, your industry, your region, or the world. And eventually what we want to do is we want to be able to log into the system. For those who are not familiar with Postman, it's an API client. We use it to run API calls to show that you can call this from outside our platform very easily. And I just authenticated into the system. And then I'm going to run an example of a token that in this case will tokenize a social security number. So the token type is called social security, and I'm providing one value, in this case, two values, an array of values that we want to tokenize, and clicking the API will return the same structure, only with tokenized information, where before I had 1, 2, 3, 4 through 9, now I have a token value that represents this data. And if I take this exact output and I detokenize it, please notice that our API had changed to detokenization, I will get the original values back. Naturally, this comes with an advanced role in value-based access requirements, who can run which tokenization on which system, on what type. It's all configurable and controlled to make sure that only the right security and only the right users are allowed to see the right data. Similar to how we tokenize an array of a single type, we can tokenize a batch of arrays. So in this case, I'm providing a credit card type token that has multiple credit cards in it, and a social security that has multiple social securities, all in one API. And when I run it, I'll get the same structure with the tokenized value back in the same tokens information, and I can also detokenize this same value back. So this is what we want to enable to the outside world. We want to create a new token that will offer our applications to call in order to tokenize and detokenize the data. And to do that, I'll go back to our tokenization self-service, and I'll select a new token here on the side that will enable me to build my own token. So I will start by giving it a name. Call it demo credit card token. Just a name. This will be the type that is exposed to the outside world. When they call our solution to tokenize or detokenize the data, they'll say, I want to tokenize from this type, demo credit card token. Category is a way to group together tokens that are related to one another. In this case, we'll call the category a demo, and a description is just a verbal description to help the people understand what this token is meant to do. So we'll call it demo token. And now we get into the scope of the token. Scope is where you define the uniqueness of the token. We mentioned before that some customers, some companies, every time they get, in our case, a certain credit card, 1, 2, 3, 4, they always want to produce the same value, no matter what. But some companies, they want to produce different values in different scopes, in different scenarios. So maybe they want to say every time I get a credit card from a certain system, let's add a scope, the system name, I want to produce the same result, but getting it from CRM will produce one value, getting it from billing will produce a different value. Or maybe I want the scope to also include the customer ID. Every time I get John, that is customer 1 in the CRM system, I will produce the same Steve as a result. But if I get John for customer number 2, or John for a different system, the billing system, it will produce a different token for me. The tokens are still going to be unique, but they're going to be associated with the scope, and the scope can be dynamically expanded or shrunk depending on the requirements that you have for the specific token. Now that we defined our scope, we can define which tokenization process, which tokenization rule is going to be applied in the background. And in this case, I'm going to select the tokenized credit card just to show you behind the scenes. We're using a model of ours called Broadway that enables us to design this type of token. It's a drag and drop type of visual way to interact with data orchestration, data processing, where in this example, you can see I'm getting this credit card as an input, and it's going through the different manipulation and transformation, including tokenizing the value, and I'm getting a new token value as an output. Now, the token that is produced is randomized, but it's a valid token. So if I go and validate whether this token value that was generated to me is a valid credit card, I can see that it really is. It's completely randomized, it's not associated with the original value, but it's a tangible value that you can use, that if your application actually validates that the credit card is valid and you're tokenizing its data, it will not break. So I defined which tokenization process behind the scenes I want to run to tokenize the data, and now I get into the expiration and the retention of the token. Do I want it to never expire? Some companies, they want to have it forever. Some companies want to define retention policies and say, I want this token to expire after 10 years. Or in our case, for the purpose of the demo, we'll do 10 seconds because we want to see the data changes. And by the way, I want to enable that if during those 10 seconds there is a call to tokenize or detokenize the same value under the same scope, I will restart my timer to another 10 seconds. Now, before I actually save this, you can actually see an example of what API you will call for tokenization or detokenization. Here I'll copy the content of the tokenization API. I will not save it yet. And I will go back to Postman and I will change our API. This is the new token. It says demo credit card token. This is the type. Here is the scope, the system. We want to, let's say, run this for a CRM and customer number 1. And here is the first token that I want to, credit card that I want to tokenize. And here is the second value. And I'll even do different formats because we want to be format preserving as well. Now, if I run it right now, I haven't yet saved the token. You can see that the system doesn't have a token that exists right now. But if I click the save button, and the token was added, I can execute the same API call, and now not only do I get a result back for a token that we just defined a few seconds ago, but it persistence with the format. If I had the -99 here, now there's -32, and I can take the same value and detokenize it. Now, since we put a retention of 10 seconds, and 10 seconds have passed, that means that the system would have automatically deleted that token, and calling the API again will produce a different value. As long as I call the API within the 10-second range, the retention will be renewed. And after 10 seconds, it will still produce the same value. And by the way, this is true even if I detokenize the value. Within the 10 seconds, I will get the response back. If I wait 10 seconds for our retention to expire, then the data will be deleted automatically by the system. You don't have to worry about manually deleting retention data. And then calling the API will say the token doesn't exist again. Let's go back quickly to our tokenization that we find under the demo category. We now have a demo credit card token that has a retention of 10 seconds with a scope of system name and customer ID. Let's remove the renewal of the timer. I'm still keeping it at 10 seconds, but I'm removing the renewal of the timer, and that means that I can call the tokenization as many times as I want, but when 10 seconds have passed, the token is going to change. I'm forcing the application to adjust to a different token. See, it was 33, now it's 88. Let's do another change. We'll go back to our token definition. We'll regain the renewal of the timer, but we'll change the scope. Now we don't want this token to apply on a customer level. We just want it to apply on a system level. So every time I get the same credit card for that system, I will produce the same result, but for a different system, I will produce a different result. So now calling this API, produce 79 here. Even if I change the customer ID, it's still the same 79. But if I change the system, let's put billing system, then it will produce a new value for me. Another functionality that exists in the solution is the ability to actually delete the token. So before I delete it, let's change the token expiration to 10 hours. And then we're going to run the same request. And now a token has been generated that will stay in the system for 10 hours. But if we want to enable to delete all these tokens and to rekey and start the retention again, I can, given the right permission, delete the token. And you can configure the system to act differently depending on different users that are calling the deletion, or different roles that are calling the deletion. In this case, I define the system to send a requirement or request to a managerial role to delete the token. Calling the delete here doesn't physically delete the data. It will have sent a requirement to a manager that says somebody requested to delete the data, go ahead and approve it, and that manager can log into the self-service and do it, or even do that through CI/CD and automation process. In this case, I can see the requests that were sent. Here is the request that we just sent to delete the data. And as a manager, I can either approve or deny the process. Log out. I need to be a different user for that purpose. And now, as a different user with the right permission, I can delete the data. And now demo that was here before is gone, and the tokens have been deleted. So we've seen a few of the modules that our data tokenization enables. We've seen how simple it is to define new token, to expose it to the outside world so systems and user can use it. But the product that K2View is designed and built on is a platform that enables us to build data product in a very efficient and very quick approach. And that gives us the ability to offer a unique mode of data tokenization that we call Tokenization 360. And simply put, instead of having a unique vault per value, we know how to integrate and correlate the data and create a vault per customer. So in our case, Joe Smith will have one vault where within this vault, you will have all the data from all the applications and product that are tokenizing data belonging to Joe Smith. It is essentially, it's a 360 view of Joe from a tokenization standpoint. And tokenizing the data using this data product in a customer level 360 view enables us to offer a few more advanced functionalities. One of them is context-aware tokenization, where before, every time I got an email address, I had no association that that email address belongs to Joe. So I just had a verbiage email and I tokenize it to a valid email address, but it's not associated with Joe whatsoever. Now inside the 360 vault that belongs to Joe, I know that his name is Joe. I know that his last name, that his first name is John, his last name is Doe, and I know that we masked that to Steve Smith. So when I get a request to tokenize his data, I know that I can tokenize it to steve.smith@company.com. So that gives you higher level of accuracy when you tokenize the value, and naturally you have a higher value by seeing the data for John across all these systems, and that enables you to very quickly react and support different data privacy requirements. The GDPR of the world, LGPD, CCPA, all these data regulations that give rights to our customer to see their data, to purge their data, to rectify their data. Now you have one place where all the data about Steve exists in one location. So a customer comes in and say, I want to know what data you hold on me. You don't have to go to hundreds of thousands of different systems. You go into just one location that stores all the data about that customer. Also, when they want to activate the right to be forgotten and delete their data, we keep the lineage to the original source systems, and we help you orchestrate the purpose of deleting that customer data or masking or tokenizing that data across the different systems. So to talk more about our data product approach, I'll pass the control back to Gil. Before we do so, we'll just ask you guys one more question. Alicia, if you can please help post the third poll question.
Yeah, thank you very much, Hod, for this comprehensive demo. Lisa, please share the third question. Is basically asking you if you wish to learn more about our multi-vault tokenization as well as tokenization 360. Let us know if you would like to get a dedicated demo of the product. Just to share with you, 87% of you guys said that you consider implementing a tokenization solution in the next 12 months. 12% are already in the process of implementing it. So it seems that you are interested. Let me just go back to wrap up what we did so far and just tell you a little bit about who is K2View. So actually, the K2View is the only platform that integrates, processes, and delivers enterprise data via real-time data products. We deliver this solution today that supports many, many use cases to some of the top Fortune 100 data-driven companies across different sectors. Actually, we have a platform that manages data products, and what we do is we integrate and unify all the data across all systems around business entities. Business entities can be anything that interests the business. It can be a customer, it can be an order, device, truck, package, or anything else. And what we do basically, when we talk about data products, we talk about four major elements. We talk about unifying all the information across all your source systems and create a holistic view of this business entity. Then, of course, we secure and govern this data product using tokenization, data masking, data encryption, etc. We keep it always fresh, and we deliver fresh data to all the consuming applications. And finally, this is a foundation that allows us to support both operational and analytical workloads. We can do it basically because we use our patented approach and unique approach, which we call micro database. And the secret sauce behind this platform is basically we generate a single micro database for each business entity instance. So for example, if you talk about customers and you need to deal with 1 million customers, as an example, we will create one micro database for each and every individual customer, where all the data of this customer will be unified and connected. And then this data will be delivered using any data integration technology to any consuming application, fresh data as the application requires it. So we support data persistency, data virtualization, many other data integration technologies. And as I said, this platform supports very many use cases. We talked today about data tokenization, but the same platform can also help organizations to create customer 360 view, to operationalize any insights which are being generated by business analytic applications and operationalize them. We also do cloud migration, including pipelining data to data lakes and data warehouses, provisioning of test data, legacy system modernization, and many more. I'm rushing here because we do have some very interesting questions which we would like to cover. So just to finish up with two case studies, we are now deployed with our data tokenization solution within a Fortune 500 payment processor. Actually, we manage 3.3 billion volts. These micro volts that Hod mentioned are credit card that we manage, and basically all the retail stores that are being served by this payment processor can use the data freely because they do not need to secure it. All the sensitive data is being managed by K2View data tokenization for this payment processor. And again, a lot of hassle of protecting the data is, of course, being reduced. A second case study is a project we run now at Comcast, a joint project with Accenture. Basically, we are tokenizing the information, the customer information, and we help Comcast to save a lot of money that they spend on different security and encryption services. And again, by centralizing on one data tokenization server, they reduce this cost and, of course, increase the security. So this is a little bit about what we do and about this. By the way, this project at Comcast is going to be live in Q3. And let's now just pick a few questions, and how do we did get some interesting ones. So one question talks about, would tokenization work on any data or only K2View data sets?
No, absolutely any data. It's designed to work on your data. It's designed to enable whatever format and data and technology that you have.
Right. Another question we got is, in case of deletion of data, how will we delete the tokenized data?
There are a few modules that enables you to do that. First, whenever it's enabled, we keep the lineage back to the source systems. We know which data we ask to be tokenized, so we keep lineage back to say, we tokenize the CRM system and that table. The PII discovery enables us to know where this original data was from. And then we can also enable a scanning of your system based on the tokenized information. So we store the tokenization. We know that it's there. We can go and search within your system where these values might exist.
Right. We do have 1 minute before they cut it off. So how do you encrypt the microvolts? There is a question.
So the microvolts are encrypted separately. There is a procedure that dynamically and virtually creates a different key. It's very important to understand that it's not that there is a table with millions of keys that tell me this is the key for this value. It's virtually created by the system when the system is installed using a master key. And it's separated and segregated such that different parts of the key are stored in different nodes in the distributed solution. So even if somebody is able to break into one of the nodes and somehow into the Java security level and somehow pieces up the key, he will get a portion of the key. He will need to do the same with the rest of the nodes to build the key so he can decrypt one individual vault that has inside an encrypted value with a different key.
Great. I think we need to stop here. Hod, thank you very much for the presentation and demo, guys. Thank you very much for your participation. I hope you've learned a lot. And by the way, you can reach us for additional demo sessions or any other type of information. Thanks a lot for joining this session.
Thank you.
Thank you all.